Hello, community. Very happy to have this chance with all of you. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I am Gerardo Lopez. I am CNCF Ambassador, Docker Captain, and Cube Astronaut. And today I will be your host. Very happy to have this chance because today we have amazing special guests talking about incredible topic, being honest. This topic is about how Kyverno can optimize policy enforcement performance for large cluster. Remember, guys, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. Please don't add anything to the chat or question that would be violation of the Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. With that, I hope that you can enjoy this presentation because, again, our special guests are incredible, ask a lot of questions, learn a lot from them, and I prefer, of course, that they can present themselves. So, guys, it is your moment. Appreciate the opportunity and all of yours.
Right, I think we can start actually before we officially start. I'll introduce myself briefly and let Khaled introduce himself, and then we'll kick off the session for today. So, hi everyone, I'm Shooting Zhao. I'm a Kyverno maintainer and also a staff engineer worked at Namada.
Yeah. Hey everyone. So my name is Khaled Amara. I'm a Kyverno contributor, and yeah, I used to work at Armata.
Awesome. Welcome, everyone. So let's start. So today we're going to dive into the global context entry feature of Kyverno and the new projections feature enhancement in the upcoming 1.14 Kyverno release. And by the end of this session, you'll understand how these features can help reduce API server loads, as well as speed up policy processing times and make sure your Kyverno policies more efficient than ever. And Khaled will take over in the second half to showcase the live demos and benchmarking results. But first, let me set up the stage by covering the key concepts. So we can start with a quick refresher on Kyverno itself. And as you may already know, Kyverno is a CNCF incubation project. It is designed as a Kubernetes native policy engine that helps you secure, automate, and manage your clusters using policy as code. And it was later extended beyond just Kubernetes, right? It allows you to apply Kyverno policies to any JSON payload. And to highlight some of the key features that we support in Kyverno, there's this validation subrule of Kyverno policy to help enforce, the configurations of your resources. The classic use case is to use the validate rules to enforce the pod security standards, and that can automatically apply to controllers because Kyverno is native to Kubernetes, so it'll handle all the pod controllers automatically when you have pod rules. And there's also mutation ability, right, to let you modify resources, not just incoming admission requests, but also the existing resources. Use cases like adding the labels to your incoming pod or the annotations to the incoming resources, or even restart the existing deployment in your cluster that can all be achieved via the Kyverno mutation subrule. And there's this addition generate ability of Kyverno, which allows users to create Kubernetes resources for use cases like automating the creation of network policies, or setting the default image pool secrets for your incoming namespaces that can all be achieved via the generate subrules. And in addition to that, there's ability of verify image signatures as well as attestations using cosign and notary to help secure like the secure security chain supply chain security. And there's a separate cleanup policy which can help remove the outdated resources by the defined schedule so that you have the periodical cleanup jobs can be scheduled in a cluster to remove some of the Kubernetes resources. And if you're familiar with Kyverno policies, you have looked at the Kyverno policies, you'll notice that they're all written in YAML format, making them really easy to read, write, and maintain, especially if you're work in Kubernetes. However, as your policies grow in number and complexity, you might run into some challenges. We're going to talk about one of those challenges in the session following, right? So imagine this scenario. Let's say if you have 10 policies that are all need to check the same data. For example, a list of allowed image registries that are stored in a config map. And when each policy is executed, Kyverno sends one API query to fetch the data from the config map. And now you have 10, then there are 10 API calls in total to fetch the same data from the config map, which results in unnecessary API server loads, and potentially it'll slower the policy processing times. And now here's, you have 10 incoming pods to be created, which matches all those 10 policies. And that results in the total number of 100 API calls, querying the same config map, say in the kube system namespace. And even worse at scale, right? This can significantly impact performance as well as scalability. So here comes the question, how can we avoid the redundancy? The global context entry is here to help. So we have introduced this concept of global context entry, which is a CRD managed by Kyverno. And it basically acts like a shared cache for external data that you can access globally across all your Kyverno policies. With the global context entry, it allows you to fetch data once and then reuse it across multiple policies, thus reducing the redundant API costs, right? So how the global context entry works is that when you created the global context entry, Kyverno will fetch the data once. Those data can be either Kubernetes resources or any data that can be accessed through the external system, right? Once Kyverno fetched those data, it'll be stored in the global context entry. And later on, if you want to reference those data, those fetch data, you can define the context block referencing the global context entry in your policy so that you can reuse the same data without fetching them every time when the policy gets executed. Right? So now let me share my screen to show you an example of what global context entry looks like. And we'll see some real world use case and how that exactly can help reduce API queries as well as speed up the policy processing times. So here, let me share my screen, this window. I hope everybody can see my screen. Looks like so. So now I'm on the Kyverno website. I think I've shared this link with Falcon. So you can access that through kyverno.io and navigate to the external data sources. You see the section about global context, right? So basically, there are two ways for you to define the resources that you want to fetch.
Hi
Okay, I
everyone.
think so.
So
We
I
have
think
any problems exactly with she, but I don't know, Khalil, if you want to continue explaining yourself, your part, while she come back. I don't know.
yeah, sure. Okay, so I can start by sharing my screen. So yeah, hi everyone. Sorry about this mishap. I think shooting was gonna talk about the global context documentation. So as she was saying, you can access it by going over to the Kyverno documentation. On the sidebar, you can find external data sources, and in it you will find the global context section. And I think I can already share the link for this documentation, so you can jump right in. So, global context, the global context feature is basically, you can think of it as caching. And I think caching is one of these topics that are like sometimes really complex and sometimes very simple. In this case, hopefully it's really simple, but it's one of these things that always comes to mind when you are trying to scale and designing new systems. So, as Shooting mentioned earlier, the global context entry introduces a new CRD, and this is how the new CRD looks. So, as you can see, it's still using the Kyverno API version. It's using version V2 Alpha 1. It's still an alpha stage development or feature. Um, yeah. So, and as with any CRD in Kubernetes, you can give it a name. This name is very important because we are gonna reference it later when referring to this specific global context entry. So under the spec, there are two types of global context entries that we support in Kyverno that you can use as a user. The first being is a Kubernetes resource. Remember, before we had global context entries when using API calls, we only supported one format, which is basically giving a URL. This URL could have been a URL to the API server, and I think we have yes, we have an example of this here. So as you can see, for URL paths, if you start with slash APIs and then the group, version, resource type, you can basically get any resource you want from the API server. This is kind of like more flexible. You can even give like parameters, whatever. But yeah, but this way is more intuitive. So that's a nice addition if you like more intuitive systems. So basically here you can specify the group, the version, the resource, and a namespace if you want. If you don't specify a namespace, then all the resources from all namespaces will be returned back to you, right? So this is the first type, and I'm gonna very quickly introduce the second type. This is the second type, okay? And as promised, I said it's more flexible. That's because you can use parameters, you can do whatever you want. So this is the old way. It's still using the same format and standard as the previous API call. You can give it basically any path you want. This doesn't have to be an API server call. It could be a call to a Kubernetes service. And like that returns IP addresses that you want to use for blocking, that returns geolocations. It can be anything you want. It's very flexible, and that is the power of the API calls feature, as well as the global context entry, of course. And coupled with this, you can find that there is a refresh interval. So for the previous one, since it's using Kubernetes objects, in, internally, and you guys don't have to think about this, but internally, we use informers and watchers to watch resources from Kubernetes. So it's a very powerful feature, given to us by Kubernetes or by the API server or by the client Go library from Kubernetes. But not everything supports it, and that's why sometimes we have to code the feature ourselves. So for the first one, there is no refresh interval because we always are up to date with the changes to objects in Kubernetes. But for the second one, we have to specify a refresh interval. That's basically, you can think of it as like the TTL, something like the TTL, where each 10 seconds we make a new request, and this request will be used to update the cache so that when you refer to it later, you can find the latest variable. Of course, this can introduce some staleness in objects, etc. But yeah, so this is the API call type, and as mentioned before, this is the Kubernetes resource type. So at a very high level, that is the CRD we are talking about, a new CRD called the Global Context Entry that will be managed by our controllers in order to populate some sort of cache, and this cache can be used later. And now we come to the part where we use this cache. Let me check if shooting is back. Okay. All right, so now we go to the part where we use the global context entry. We can find that part here. All right, so in each Kyverno policy, we have something called the context. The context is basically, you can think of it as template variables. This is a very simple explanation for it, where you can store some sort of variables whose value can be loaded somehow. Well, you don't have to think about this somehow. In this case, we will, but not now. And you can use this variable anywhere in the policy. So you can use it in the validation logic. You can maybe have a context variable that has a list of IPs, and in the validation logic, you say that the API request or whatever has to be from these IPs. So whitelisting or blacklisting, you can do whatever you want with it. So this is the context, the Kyverno context. And beneath it, you can define any number of context variables. In this one, we are defining allocation context variable. So this is the variable. You can refer to it later anywhere in the policy. And this is its value. In here, we tell Kyverno that the value will be gotten from the global context entry. So whenever you see a global reference, you know for sure that this is going to be retrieved from the global context entry. Of course, we need to have a name for the global context entry. So in here, we can specify the name Redis data, and of course, there has to be a corresponding global context entry. And finally, there is a James path expression that you can use to scope down the data. Like if say you have multiple addresses and you want a certain if there is an address and there is a street, a country, you only want the city. So can you scope it down to the city, and you can compare it London, Paris, New York, whatever. Yeah, use it in the validation logic. So at a very high level, this is the global context entry feature. And, of course, there are some more powerful feature. So if you have a certain service that requires you to specify your own CA bundle, then of course, you can do that here, right? So there is a feature for, advanced use cases that you can use whenever you want. Of course, you have to make sure that there is a possibility that the data gotten from API call is stale because of the refresh interval could be a little bit longer than expected. But yeah, you can always, it's always a balance. You have to choose whether you have very small refresh intervals or very large refresh intervals. But even if you have very small refresh intervals, that still should be very helpful, because now if you have 10 policies making the same API request, you can do it only once once for all the other policies. You don't have to do it once per policy, right? All right, let me see if shooting can continue the stream. Shooting, are you?
Right now, Khaled, we are receiving a lot of shares. People is very happy with your presentation. So people from Colombia, from Mexico, around the world is watching the session. So no question for the moment. Continue doing, because it is amazing.
Right. Thanks, Malcolm. Okay. Hello, guys. Okay. So I'm gonna go over really quickly around how it works. So I had this. Very simple system design for how it works, and I'm gonna basically try to map between what we see here and what we already discussed in the documentation. So as you can see, there is an entry, and this entry is basically what we talked about when we mentioned the CRD. So this is the CRD, let's say, yeah, this one. So this is the entry. Whenever we get a new entry, well, this goes directly to the controller, and the controller basically does the API call itself. Like, say, for instance, this is an API call here. So it does the API call, and whatever result it retrieves, it will put directly into the cache. So this is an in-memory cache. It's not a disk cache, it's an in-memory cache. It's volatile. It will go away whenever Kyverno shuts down or encounters any problem. But it can rebuild it very quickly, so that shouldn't be a problem. And in here, you will find the context, which is the very centric thing where around which the global context entry is built. So as I said, the global context entry is one type of context variables. There are many other types, but this is the type that we are discussing today. So what happens is that whenever you get a new policy, say this policy has a global reference, like as we have seen here. So if there is a global reference, right? Well, Kyverno will know for sure that we are trying to retrieve this value from a global context entry. So it will go to the loader. It will a loader will do basically everything. Some types of some types of context variables can be preloaded, as in they are already in the context. But in our case, we use a deferred loader. A deferred loader as in that it accesses the variable at the value at runtime. So whenever, if we have like a policy for pods, whenever we create a new pod, we go to the loader. The loader will try to retrieve the value from the context, but the context may not have the value because it's a deferred one. I know it's not in this drawing, but basically the loader will go to the controller, and the controller will go to the will populate the cache, and the cache will put the value in the context. So this is at high level how the global context entry feature works. And now I'm gonna hop on to VS Code here, where I hopefully can show you something in action and maybe show you how this improves the performance, the advantages of each type over the other. So I'm gonna start with the very simple policy that uses API call. This is a policy that I got from our policy registry. We already have like ready to use policies that anyone can find useful if they are getting started with Kyverno. There are policies that handle pod security policies, basically any popular use case, you can sort of like find a policy there. So for this policy, it's called unique ingress host because what it does is the following. It matches ingresses. So for each incoming ingress, and let's call this like the matched resource, basically what we are trying to, compare against, what we are trying to validate. We are validating ingresses. So whenever a new ingress gets into the cluster, of course, it would have like a host. So we want to make sure that this host is unique across the cluster. So basically, no repeated hosts. No two ingresses can point to the same host. And as you can imagine, if like we have a very large cluster with like billions of hosts, then of course this is gonna take like forever. If we each time we get like a new ingress, we have to make a query to all the ingresses in the cluster. We are gonna see this in action, and we are gonna see how much time it takes to do this. So we have multiple rules, namely 3 rules. The first one is the check single host create. So this happens, as you can see in the P condition, this happens on policy creation, sorry, on ingress creation. So whenever a new ingress gets created, this rule will trigger. So what does this rule do? This is the context that we talked about, the thing that stores variables that can be accessed later. We are gonna see it in action. So we define a variable named hosts. The variable named hosts will basically get its value from an API call. So this is, remember guys, this is not the global context entry. This is the previous feature, the API calls. So in the API calls, you have to specify, of course, the URL path. And since it starts with /APIs, then of course we know that this is a request that's going to the API server. What it's trying to retrieve is basically all the ingresses. So this request will retrieve all the ingresses, right, from the cluster. And then we apply a gems path expression that tries to get all the hosts right? So this gems path expression, basically you will get all the hosts from all the items. The items here being the ingresses. So this request will return like say 1000 ingress. Each one of them is named an item. So for each item, we will access the spec, the rules. For each rule of them, we are going to access the host. This will return an array of hosts. So this should look like, basically like this. So we have an array, we have host 1 and host 2. Maybe this is coming from the, first ingress, this is coming from the second ingress. Maybe they are coming from the same ingress but different rules. But this is the end result of this James path expression. And then in the policy itself, as you can see, we are gonna use the variable here, and this is what I mean by template variable. Template variable means that you can replace the value of the variable, the key of the variable with its value. So if you say like hosts here, and you put it like this, well, it's gonna be templated away or basically replaced with the value of the hosts variable, which is, as we talked about, this array, the hosts 1 and hosts 2. And in here, we're gonna find another template variable. Well, this time it's not a context variable, it comes directly from the object itself. So this is the incoming ingress, the new ingress that's getting created, like say the third ingress. Say we already had like ingress 1 and ingress 2 that had these two hosts, and now we are creating a new third ingress. Well, it's going to basically access the spec of this ingress, the rules, and for each rule, it's going to access the host. And basically checking if any of these hosts is already in the array that we already retrieved from existing ingresses. So again, because there is a lot of ingresses here, we already have two ingresses in the cluster, one of them using the host 1, and the second is using host 2, right? And then we get a request to create a third ingress. The third ingress, say, is using a new host, say host 3. So what this is doing is basically accessing the new host. So like here, it's going to be host 3, right? And it's comparing this to the already existing hosts or the hosts of already existing ingresses. It will deny it if it already exists in this array. So if host 3 exists in this array, it will deny the request. So the ingress won't be accepted into the cluster. It will be rejected, right? So this is what this rule does, right? And very quickly, there is a very similar rule here that's called check single host update. And I'm gonna later you'll understand why we are mentioning this rule specifically. But again, it's matching against ingresses. It has a precondition for only updates. So only for updates to the ingress that we are gonna trigger this rule. And what it does is, again, it has a variable named all hosts. It sends a request to the API server for all ingresses in the cluster. And it has a gems path expression that for each item, it's gonna do a query where it's trying to check whether the UID is equal to the UID of the incoming object, and it will access the hosts for all rules of this ingress, right? So we don't have to think about this really, other than the fact that we require access to runtime access, as in this is gonna be different for each incoming request. For each incoming new ingress or update, to the ingress, we will require runtime access because we need to understand which ingress is being updated, right? And again, we are gonna do a very simple check, checking the new hosts in the update to the all hosts variable. And there is a third rule here that I'm not gonna go over because it doesn't have any API calls. So the global context entry shines when we have like API calls. Basically, when we have any type of API calls, whether it's to the API server or to a Kubernetes service. So as you can see here, guys, what happens is, let's take for instance the first rule. We have like two existing ingresses, or say 1,000 existing ingresses from ingress 1 to ingress 1,000 that have hosts from host 1 to host 1,000, right? When creating a new ingress, what I expect is that, well, if its host is like 1,001 or anything other than from 1 and 1,000, it should be admitted to the cluster. If it has a host that already exists in the cluster, then it should be rejected. This is what the policy does. But what actually happens is that whenever a new ingress is created, the API request will be done each time. So imagine I have 1,000 ingresses and I'm creating another 1,000. Like I have ingresses from 1 to 1,000, and I'm creating ingresses from 1,000 to 2,000, right? So for each request, for each new ingress I'm gonna create, which are 1,000, I'm gonna do this API request. As you can imagine, that's very expensive because, again, the resulting data from this API request is huge because we have our 1,000 ingresses in the cluster. That's a large number. The request is going to be in like maybe in the megabytes. Like it's a very large response, right? So I'm going to do this API call 1,000 times, which means returning like upwards of 1 gigabyte bandwidth just to get the ingresses. I mean, wouldn't it be better if I like got the ingresses once, cached them, and then later did all I want with the James path expression? And this is exactly where the global context entry comes in. So it's the same example. It's going to be the same example for all three of these policies. Nothing is going to change. The only change here is that we created a global context entry, the CRD we talked about, right? And for this global context entry, so it's named ingresses, and it's tracking ingresses in all namespaces. Since I didn't specify a namespace, then it's tracking the ingresses in all namespaces. And if we scroll down here and come to the context, remember that the context here had a type of API call. Now it's different. Now the context here has a type of global reference because it's trying to reference a global context entry, right? So now here we specify the name of the global context entry, which is this one, right? And then we do any James path expression that we want to do. So for instance, it's the same James path as before. For each item in the array, we access the spec, the rules, and for each rule, we access the host. So again, this is gonna return like host 1 and host 2 and host 3, etc. Right? Okay, and everything remains the same. So you can imagine that this is not a lot of work to do in order to gain performance. If you already have an existing policy that uses an API call, you can easily convert it into a global context entry and benefit from the performance uplift. So what is the performance uplift, you might ask? And that's a really good question. And we can try this right now. So what I'm doing here is that
Alex,
yeah,
right now,
fine.
the session is amazing. The people is asking questions in the chat. The chat is on fire right now, asking questions. So I think so it's a good moment to probably answer the question. So what do you think if we give a little minutes in order to answer the question from the community?
Sure, yeah, that sounds good. Sounds good.
Okay, let me show you the community. The first question is
Mhm.
from Fabrizio Sgura. How does Kyverno's approach to policy enforcement performance in a large cluster compared to other Kubernetes policy management strategies, such as Open Policy Agent, Gatekeeper, and others? What do you think?
Well, that's a great question. So I don't really want to comment on the strategies of other, uh, policy enforcement solutions. Of course, we have studied them in order to make sure that if there is anything that we can do, that we are going to do. But I can say that we take performance in large clusters very seriously. Like we had a lot of discussions regarding this. We tried many approaches, including the global context entry. As a matter of fact, the global context entry first arose as a problem uh, uh, that we tried to solve regarding performance. And right now we are exploring validating policies, and we incorporated scale testing in our CI. So in our CI now we have like scale testing. Every new feature is tested against performance scaling and scale. Scale testing, load testing. We use K6 for load testing, and we are trying to do compilations. So basically, Right now, we are trying to support cell expressions in our policies, and we are trying to compile these expressions for performance. So yeah, I think that's an interesting area where we are trying a lot of things in order to improve performance in Kyverno. And if
Nice.
yeah,
Yeah, just wanted to add to that. For example, for the validation policy, Kyverno only process enforce validated rules during the emission review time and save out the audit policies to the background process. So that won't take any execution latency that'll be added up to the overall emission review latency. And moving forward, Kubernetes start supporting validating emission policy as well as mutating emission policy. And we're working on the integration with those two built-in solutions in Kyverno so that some of the logic can be performed at the API server side. So there won't be any emission review latency added when you admitting resources, and instead all the decisions are made in the API server itself, so that that can definitely benefits the large clusters.
I
yeah.
have another other question because again I have a couple of questions. It is the moment to answer, and thank you so much. Joao Pedro Alcantara. I have been trying to use Kyverno to change image registry of pods, but after applying the policy, the replica set are failing and pods are not being created. Any idea?
So that's probably because of the autogen feature of Kyverno, because I assume this policy applies to pod. And by default, managed pod by pod controllers cannot be mutated in anyways, because the pod controllers will revert the changes that you made to that managed pod. So if you're changing the image registry of that pod, but that change doesn't comply with the replica settings, I believe the replica set controller will fail that pod creation. I think that's maybe the reason, but if it's not, you can reach us on Kyverno, like Slack channels under Kubernetes workspace, so we can further help.
Nice. Additionally, if an organization is considering migrating from Open Policy Agent or other policy engine to Kyverno, what would be a good path for such a migration? And are there any best practice?
Yeah, I think on the Kyverno website, we have published the blog post regarding the migration from the old PSP pod security policies to Kyverno, and similarly, the classic use cases to enforce the pod security standards. So you can find some of the articles from the Kyverno website. And also, regarding the use cases that you have, we can also help converting your other policies to Kyverno policies. And yeah, I think those are some of the things that we can help, but would love to understand more about the use case and see how we can help. I think, let me see if I can find some of the links, but please go ahead with the questions.
Yeah, exactly. Think so. Uh, the remaining of the session, guys, community, we have at least 20 minutes. If you have more questions, please write the questions into the chat. And so we continue with the presentation. What do you think, guys? Continue with this amazing demo that we are presenting? Right. Okay.
All right. Yeah. Okay. Thanks, Falcon. All right. So I was gonna show you guys how much performance uplift we can get from this simple policy. So what I'm doing here is basically I'm running an instance of Kyverno right now, and using this we created a little test. We were talking about skill testing earlier. Well, we use that extensively, and one of this is basically any feature that we are gonna create, we have to validate that it's very beneficial to Kyverno, and that's what we did. So we have here a simple test, right? This test has a setup. For the setup, all it does is basically create, like say, 100 ingresses. So it's creating an ingresses from 1 to 100. So we have already existing 100 ingresses. Each of them is gonna have like a different host. So like example 1, example 2, example 3, etc. Right? So this is the setup. We only create 100 ingresses, and the actual test itself is basically creating an ingress with the host name example 50. Now, remember, example 50 is already created here, like from 100 to from 1 to 100 is already created. So example 50 shouldn't be created because, well, the host name already exists in another ingress. What we are trying to do is create this, ingress any number of times that we specify and see how much performance we can expect from this. Again, we expect it to get blocked. We just want to see how much time it takes until to block a certain number of ingresses. And for this, I'm gonna start by having 1,000 ingresses. So I'm trying to create the ingress 1,000 times. An ingress that should be blocked because it has a host name that already exists in the cluster. Now, if I run this, like if I say test API call, right? So this is the interface of K6. Now it's gonna take some time, and that's understandable. So if you can guys like bear with me for a second here, but you won't have to do this again. It's just for the API call for the global context entry. It should be very instant. As you can see, it's taking a little bit of time, and that shows in the stats of the numbers. As you can see here, to block 1,000 ingress or 1,000 requests, it took over 1 second per request, right? And that's like a lot of time. That's a very large time when you have a performance critical application that should run in the milliseconds. That's a very large time, right? And let's see how much we can improve on this using the projection policy. The global context policy. So for the other test here, we are gonna create the global context policy that we just talked about, having the global context entry and the policy itself, and run the test. So let's remember this was 1 second, 136 seconds. Now let's run the global context entry test and see how much it's gonna take. Now you won't have to bear with me a lot because it's finished right away. And as you can see, the average latency here is like around 134 milliseconds for 1,000 requests. Now that's like 10-folds increase in the performance just by switching to the global context entry. But we are not done yet. I mean, if you think that is great, then it's gonna get even greater. So I'm gonna go back here quickly over to this policy. So if you remember, what we did is that we created a global context entry and used it to reference, used it in the context to reference the already existing value in the cache. What we did here is save network calls. So in the test that I just talked about, we are creating 1,000 new ingresses. Each one of them is gonna create a network request to the API server in order to get the existing ingresses. But now we only have to do it once. Like we have to make the we have to make the network request only once per the 1,000 requests, and that's why we get the 1,000 uplifts. But the only thing missing is that we are applying the James path expression at runtime. So for each ingress in the new ingresses created, the 1,000 ones, we are gonna apply the James path expression. Now this isn't network, this isn't I/O, and of course it's not as slow as I/O or network requests, but still we could get an improvement from not applying this at runtime, but applying it when updating the already existing ingress itself. So now we are moving to projections. What are projections? Put simply, projections are James path expressions that's applied on write time, not on read time. So basically, when caching, not when reading from the cache. When writing to the cache, we apply the James path expression, not when reading from it. Here in the global context entry, when we match a resource, a new resource that we want to apply the policy on, we get the value from the cache, from the global context entry, and then apply the James path expression. So we have to apply it 1,000 times. again, let's open this test. Here it is. So again, we are creating 100 indices. This is the right phase, right? So we are creating 100 indices. This is for the setup, for the right phase, the already existing indices. And then we are applying or creating this ingress 1000 times. So creating 1000 ingresses, 1000 ingresses, and this is the read phase, right? Because now we want to apply the policy, so we try to read the already existing 100. So what projections does is that when writing, like in this phase, when writing here, if we are gonna create a new ingress, then we are gonna do the computation and then store only the computation. As you can imagine, the very first benefit of this is that we have reduced memory usage. So an ingress is very large. It can have like a huge amount of text, right? But the host could be very simple, you know. So what if we stored only the host? We didn't have to store the entire ingress. We only stored the host. So the very first benefit of projections is that we can reduce the memory usage. This is what happens here. For the first 100 ingresses, we are gonna get all their hosts and then store them in the cache and then forget about anything else, right? We don't care about any other field in the ingress itself. And then in the actual usage itself, if you can see here in the context, again, we are using the same type of global of context variables, the global reference, and in the name, we specify the name of the global context entry, this one, and then we specify the name of the projection because there could be multiple projections. So as you can see, we specify, where was it? Yeah, here we specify the name of the projection. So the name of the CRD or the name of the global context entry, period, the name of the projection. This will return the value of the projection itself. And then again, in usage, you can use the context variable just like any other context variable by substituting its value here. So this will have the array that we already talked about once again, which is host 1, host 2, and etc. Of course. So this should result in improved performance, mainly because we won't have to apply James path multiple times. We will only apply it once. And again, I have the numbers to show for this. So if you remember, the number for the API call policy was like 1 second, 26 milliseconds. 206 milliseconds. And for the global context entry, it was 148 milliseconds. For that projection, well, it will be very fast, blazingly fast. In fact, it's already done. And as you can see here, the duration is like 70 milliseconds, which is half what it was for the global context entry policy. That's like 2-fold increase or 20-fold increase over the original time coming from the API call policy. And this isn't even the full of it yet, because the projection feature is very beneficial. Sorry, here, this one is very beneficial if you want to use the hosts like in multiple places. Like say you had not one policy. Here I have only one policy. But what if you had like 10 policies, all needing an access for the host? And there could be a use case for this. Well, if you use just the global context entry, you're gonna get like average time. Not good, not very bad. But for the API call, forget it. It's gonna be very bad. And that's the power of projections, basically. And you might be wondering, what if I want to apply runtime James path? Well, remember the second rule? Well, the second rule needed access to the current metadata of the object, like the admitted object, the objects that we match it against, the new ingress that's getting into the cluster. So it required runtime information from this object. And thus, we couldn't really apply this James path expression as a projection. Well, you still have access to runtime James path expressions. It's gonna make the policy slower, but at this point it's a necessity. You can imagine if this rule didn't exist, well, the 77 millisecond would be obliterated. It might even get into the single digits zone. And yeah, this is a policy that doesn't use any API calls, so it wouldn't benefit at all from this feature. But yeah, this is in essence the global context entry and the new projections features that we are launching with Kyverno 114. Now, let me hand over to Shooting to see if she has anything else to say, and then maybe guys, we can have like a little Q&A session to discuss anything that you have.
Nice, of course. Right now we have a couple of questions. So thank you so much. Let me share a couple of them. So Enrique Tejeda, great session. I have a question. What are the best resource tuning strategies and deployment patterns to optimize Kyverno in large-scale Kubernetes clusters?
That's a good question. Specifically for deployment, I think one of the features that we mentioned earlier, which is called AutoGen, it'll help enforce all the pod controllers. You can customize that to apply to deployment only, so that you don't need to repeatedly apply all the pod rules to your pod itself, instead to the high level pod controller, in this case, deployment. And regarding in the large cluster, I think there are a few things that we can consider, right? If you're trying to enforce during the emission review time, of course, you're going to have to enforce validate rules. But if not, if you only want to, report violations and see if there's any configuration issues with the existing deployments, you can turn off the emission so that it won't execute any or evaluate any emission request. It'll instead report all the violations in the format of policy report, which is the CRD proposed by the policy working group. So you can visualize all the violations and all the applied rules in the policy report instead of enforcing things at the emission review time.
Okay, thank you. Other question from Mateo by Winnie. Sorry, Mateo, if I'm not pronouncing your last name very well. Mateo said, "What have we have some issue deploying Kyverno in a Kubernetes cluster managed by Argo CD. At some point, the load of the Cube API server is too much, and the cluster becomes unresponsive. Any suggestion?"
Yeah, I think we have the nodes for the Argo CD user particularly. I can put that in the chat. So Falco, if you can help sharing that publicly. And I believe Argo CD by default will revert any changes that is different from its own settings. And here you might need to set, the enable the replace in the sync option, or ignore the difference in the target resources. So there's a nodes for Argo CD users, so that two applications can run on Argo CD, don't fight with each other and try to revert changes made to the resources.
Got it. Thank you. Um, okay, have another one. It is about, especially from Fabrizio. Thank you, Fabrizio, again. Especially, what would be the key differences in performance and scalability when managing policies and at scale?
So yeah, there are multiple ways to improve the overall performance, and for different policy or rule types, you can have different options. But with the global context entry that we like explained in this session, it'll reduce the API queries in total and offload the API server load. And also with the caching ability, you are able to optimize the in-memory cache that are stored in the global context entry. But the overall performance, let's say if you have mutate policies, you can consider JSON patches instead of strategic merge patch to speed up the policy processing times. And there's a lot of different use cases that we can help in optimizing performance. And there's also the scaling test data that we published for each minor Kyverno release. So let me share that link again privately. So you can refer that to set up the default resource allocations for your Kyverno controller so that it'll help you know set its max capacity of the processing.
Yeah, and I want to add to this for Fabrizio. So you asked what is the key differences between Kyverno and other projects. Well, I can tell you that at Kyverno, I think one policy direction that we are going into is basically having minimal interaction between when the policy is received from the API server until the result is, you know, put back to the API server. So I think we are doing everything we can to optimize performance from trying to use the new validating admission policies from Kubernetes to basically if we don't have to touch it, we won't touch it. And if literally we wanna we wanna build around the Kubernetes around already existing solutions, we want to supplement it, not add our own basically implementation or our own compiler, etc. So yeah, I think basically just minimal interactions, and I think that's why Kyverno will scale, especially in the future when our vision is realized.
Nice, guys. No more question for the community. Thank you so much. Maybe amazing session. Probably, guys, if you can share with us what is the latest, or what is the way that you can communicate or the people can reach with you. So I don't know. Tell us, Slack, web page, what way the people can use in order to contact you or maybe collaborate. Why not in the Kyverno project?
Sure. I'm sharing this tab again from Kyverno.io. There's a community tab here. You can reach out to us through Slack channels, for any of your Kyverno questions, or join our public meetings. We have community meetings as well as maintainer meetings to discuss the issues and the plans, the roadmaps for Kyverno. So if you have any use case that you want us to support, we can discuss that in the meeting together. And of course, the GitHub issues, feel free to file anything, the feature requests or the issues that you found during like your uh, with with your experience with Kyverno.
Okay, nice. I think so. That's it. Anything else that what you want to share, or we are done right now? All is good.
Yeah, I think it's good on my side. Khaled, do
Yeah,
you have anything to add?
yeah, I'm good.
Okay, guys. Thank you again, everyone. Thank you so much for joining the latest episode of Cloud Native Live. We have amazing presentation, amazing speakers. So we enjoyed the interaction and question from the audience. Thank you again for joining today, and we hope to see you again in the future soon. Take care and see you soon.
Thank
Bye,
you for
everyone.
having us.